Okay, guys, so we've done like one sample confidence intervals. Now, if you recall from business stats, the next thing we're going to look at is going to be two confidence intervals. So imagine, let's just start off with a little business scenario. We have two websites, two versions of a website, A and B. So we have this is a website, and this is a website. Now, what Google can do for you is it can send about, say we have 1,000 random customers. What Google can do is it can route like half to A and half to B. So we're going to have 500 customers in A and 500 in B. And the idea and what we're trying to do is we're trying to work out, which website, A or B, um, actually has maybe, better profit, more people converting. So imagine this, we actually calculate the profit per visit for each of these people. So we have N1, which is the number of people who visit the first website. We have X bar 1, which is going to be my mean spend. We're going to have S1, which is the standard deviation. And exactly the same for website 2. We've got N2, X bar 2, and S2. Now, we can calculate these guys, but we want to estimate for the population. So we kind of want to know what's the true difference between mu1 and mu2 that it spends for each website, because then we can actually work out, given that, whether it's worth implementing, which website to implement, or if one website is a new website, is it worth implementing that website? So that's what we're trying to find out, and these are the things that we're trying to calculate. Okay, so let's go with blue now. So this is actually another sampling distribution. If N1 is greater or equal to 50, and said some books will actually use 30 for this, then we can say the distribution the sampling distribution is going to be normal. It's going to have a mean of, the expected value of the difference between the means is going to be of the population. And the standard error is going to be now all this is just some way of combining the standard error for the two distributions. It's like, almost like, think of it as almost like an average of the error between the two, between sigma 1 and sigma 2. And of course, if we don't know the population values, then we're going to be S1 squared over M1 plus S2 squared all over N2. So that's the standard error of the distribution. So what we're going to do is we're now going to kind of think of this in terms of a confidence interval. So this is the sampling distribution. It's kind of centered around mu1 minus mu2. And we have basically we have a lot of X bar 1s minus X bar 2s. And again, we kind of, with a confidence interval, we flip it around so that X bar 1 minus X bar 2 is at the center. So now let's just do the confidence interval straight out. So we've got 100%, 1 minus alpha confidence interval. For mu1 minus mu2. Now it's centered at x bar 1 minus x bar 2. But plus or minus, and again, we have z alpha over 2. This is a normal distribution times the standard error. So it's times and this guy here is the margin of error, which we're adding and subtracting. So again, we could just draw it here. This is my 1 minus alpha, my alpha. And it's exactly the same as before, except we're actually doing the difference in the middle. And this is my standard error. I'll just put SE here. Sorry, my standard error. And minus z alpha over 2 times my standard error. So that's my z confidence interval. And again, we've got, let's just draw it like this. We have x bar 1 minus x bar 2 in the center. And then we have margin of error and the margin of error. Okay. Now, again, we can use this when we have two large samples. Now, if we have large, remember we said the t-distribution can pretty much be used for large sample sizes, and a lot of statisticians prefer it. But if we have small sample sizes and we have normally distributed variables, then we can actually use the t-distribution. Clear the canvas. And what we're going to do is we're going to do the t-distribution. Now, I promise you, this is absolutely horrible. It's a little bit horrible. So the confidence interval for the t-distribution, so 100 minus 100%, 1 minus alpha, confidence interval. For t-distribution. And this is going to be x bar 1 minus x bar 2 plus or minus t alpha over 2. Now this time, as we're combining distributions, we have n1 plus n2, but we've calculated 2 means this time, so we lose 2 degrees of freedom. So we have degrees of freedom is n1 plus n2 minus 2. So t alpha over 2, square root. Then we have this measure, and it's similar to what's happened with the z. We have this pooled standard deviation, which we kind of, again, we divide by n, but in a slightly different way. And this guy is just kind of a weighted sum of the standard deviations for the original samples. Now, for this class, we're not going to do these calculations by hand. I'm sure you love this stuff in business stats. I know when I taught it, this was everybody's favorite part. And basically all we're doing, this pooled standard deviation, both pooled variances, we're taking n minus 1 times the variance for the first group, n minus 2 times the variance for the second group, and then just dividing by n1 plus n2 minus 2, degrees of freedom, or pretty much the overall n. So that's the confidence interval for t. But again, don't need to worry about the formulas too much. Just be aware that in all of these, x bar 1 minus x bar 2 is down here. You know, this guy here is the margin of error. And then we have the margin of error. Okay, now let's get back to R. So we actually have a data set, and this I actually created this data set myself. This is called A/B testing. And we're going to have a 95% confidence interval, so alpha equals 0.05. Now, in this data set, basically we got 500 people visiting each website. Now, in this data set, the ends are even. That's not necessarily always the case. You can have differing ends. You could have like 400 people to website 1 and 400 people to website 2. Now, we're going to calculate the standard error. So there is the variance, the sigma squared. And remember, we did it for group 1 and group 2. So A/B testing. Now, this notation here means, I mentioned this notation next week, the bracket notation. Before the comma is the rows. We're not specifying, so we're taking every rows and we're taking the first column. So we're basically taking everything in the first column of that data frame. And we're calculating the variance. And then we're dividing it by n. So this is just that first formula I showed you. And then we do exactly the same for the second group. And then we kind of square root it. So that's our standard error. Just that formula I showed you when we did the combined z-test. Now we want the x bar 1 minus x bar 2. Now the margin of error is, again, as I said, you have to use the kind of the engineering, more mathy z. Q norm gives me my z value. And when we say z alpha over 2, here it's to the right of the distribution, so it's 1 minus alpha over 2. We're taking it cumulatively. And then we do the final confidence interval. So it's just we're adding this margin of error to the mean and subtracting the margin of error to the mean. This is the confidence interval. And we can see that we're 95% sure, or in the long run 95 out of 100 times, that the difference between the websites is from -9 to 5.6. So that's the kind of the confidence interval for the websites. Just make sure I had the right alpha. Yeah, I had the wrong alpha for some reason. I don't know what happened there. I guess I didn't run my code properly. So with alpha, I must have been using an old n or something. N, standard error, the difference between the means. I think that was it. I think I used an old n. I didn't update it. And the margin of error, and then the confidence interval. I thought that confidence interval isn't what I was expecting. So there we go. The difference is between x1 minus x2 is between -3 and 0.5. Now, because x1 minus x2 is negative, that means that x2 is bigger than x1. Now, we can do the same with the t-test. I'm not going to ask you to program in that horrible formula. So we can just run the t-test. We do group 1, we do group 2, and we give the confidence level 0.95. Now, important, we put whether it's paired or not. We're putting paired is false. And if you call back to business stats 2, if we're paired, we're running the paired t-test. So, for example, we would actually consider each item, each row, to be a subject. So with a paired test, we would like, for example, have a consumer and they would test both website 1 and website 2. But we're not going to be bothered with paired tests here. They're not really used in kind of large-scale data analysis. So we run the t-test as before, and we have the confidence interval. And you see it's very similar to the z-test. There's a slight difference. And if you go to the notes, I actually have a little scenario. So we have the difference, website 2 gets more return than website 1. But imagine we're using website 2, website 1, and it's going to cost us $10,000 to implement website 2. And we're going to have 30,000 customers. We're going to do a bit of profit and loss. So this is this was the lowest increase for website 2 over website 1 for the confidence interval. This was the highest increase, and we work out how much extra profit we'd make from website 2 and subtract it by the cost of implementing website 2. So There we go. That is the two sample confidence interval.